Welcome, everyone. Okay, let's dive into this. Today, we're doing something a bit different. We're immersing ourselves in a completely new kind of language explainer. You know those traditional, clunky, boring lecture formats? Yeah, we're completely ditching those. Instead, we're going to experience these essential STEM vocabulary words in their absolute most natural habitat. First up, we're going to establish the fundamental terms, directly and visually. I really want you to just sit back and let the screen do the teaching here. We'll take our time, keep things beautifully uncluttered, and let these words truly sink in before we ever see them in action.
Resolve. We use trig to resolve a force into horizontal and vertical components.
Quadratic formula. Use the quadratic formula to solve the equation. Graph a function. Always graph the function if you want to understand its behavior. Vector addition. We used vector addition to determine the resultant force. Tip to tail. Stick the vector's tip to tail before drawing the resultant. Transversal. A transversal cuts two parallel lines in the back of your head. Keep this formula in the back of your head.
Now, what's really interesting about this slide is how fundamental this theorem is across absolutely every discipline. Pythagorean theorem. Use the Pythagorean theorem to find the missing side.
Arbitrary triangle. Consider an arbitrary triangle ABC. Law of signs. Remember the law of signs before multiplying? Opposite values. Plus 5 and minus 5 are opposite values.
Plug in medallius. In one fell swoop. We solve the problem in one fell swoop.
Boo-boo. Oops, that was a boo-boo.
Corrupt system. People believe it is a corrupt system.
Am I that scary? Am I that scary? I hope not.
Let's nosedive into today's lesson. All right, let's move on and see exactly how these concepts build on one another. Discernible. The instructor explained the concept in a discernible fashion.
On the first day of our engineering review class, the instructor smiled and said, "Let's nosedive into today's lesson." We started with trig, learning how to use vector addition by placing vectors tip to tail. Then he drew an arbitrary triangle and reminded us of the Pythagorean theorem. He told us to keep these ideas in the back of our heads because they would appear throughout the course. Next, a transversal crossed two parallel lines, and we identified the angle relationships. After that, we learned how to graph a function and solve equations using the quadratic formula. We plugged in different values and carefully applied the law of signs whenever we encountered opposite values. To our surprise, we reached the solution in one fell swoop. The instructor laughed and said, "Oops, that was a boo-boo," after making a small calculation mistake. He corrected it quickly and continued explaining the solution in a discernible fashion, making every step easy to follow. Soon, the pattern became discernible to everyone in the classroom. At the end of the lesson, one student hesitated to ask a question. The instructor smiled and joked, "Am I that scary? I hope not." Everyone laughed. As we packed up our books, someone commented that studying engineering is much fairer than working in a corrupt system because success comes from understanding the concepts and practicing consistently.
So the truly crucial point here is how wonderfully all of these terms function together when we map them out in a real narrative. Let's do a rapid, holistic review to lock this first batch right into your long-term memory. We began with trig and the quadratic formula. We learned how to graph a function, and we utilized vector addition by sticking vectors tip to tail. We observed exactly how a transversal cuts right through parallel lines, and we made sure to keep all of these core ideas firmly in the back of your head. Finally, we relied on the Pythagorean theorem to find missing sides even when looking at a completely arbitrary triangle.
Continuing our review of the second half, we saw just how essential it is to remember the law of signs, especially when we're dealing with opposite values. We practiced how to neatly plug in our numbers so we could solve those equations in one fell swoop. We realized that a minor calculation mistake is nothing more than a boo-boo, and we neutrally explored the phrasing around a corrupt system. Our instructor even lightened the mood by asking, "Am I that scary?" proving that we can confidently nosedive into our studies, knowing everything will be laid out in a perfectly discernible fashion. Now that you possess all of these fantastic tools, what complex English topic will you nosedive into next?